Hello, Ellen. Welcome to have you here. I'm really excited to our conversation. Just to get you introduced briefly, from what I've seen, you were 16 years old. You learned rockets building from YouTube to make your own rockets. You were on the cover of Monaco Matin and currently have your own education course on rocket building for Mars Academy to help curious students learn about the fascinating world of rocketry. I don't know if I gave you a good introduction, but please tell us more about who you are.
You gave a good introduction, I have to say. Thank you for that. Yeah, I think you gave the most part is good. What can I tell you more? I can tell you how I started, if you want.
Yes, that's amazing. That would be my first question. Like, when did you realize you were interested in rocket building?
Well, the thing is that in 2019, I went to a conference in Monaco called Above and Beyond. And at that conference, there was one of the greatest astronauts of all. It was Buzz Aldrin, so the second man that stepped foot on the moon. And it was there, like sitting alone. And I said, why not go there and, interact, having conversation. I was really stressful. And I went there, and Buzz Aldrin gave me a great, great conversation. We had an amazing conversation about space and how we went to the moon. We shook hand, so that was amazing to shook hand with a man that touched the moon. And there, I think my passion really went growing. Maybe I was passionate before, but that was the key moment that helped me out to, start this dream of sending people to Mars and want to be part of space exploration.
And how long did it take you from the first time you wanted to see what this is all about to actually building your own first rocket?
Right. So it was a long time for me because at the first moment I really wanted to build rockets, but I didn't know how to build rockets. And the journey to learn took me 3 years. 3 years of maybe seeing an article about how to build rockets, to a tutorial on how to build rockets on YouTube, to do some research, reading some books, and things like that. And after I tried to make rockets with the school, but the school didn't want it. And then I said, why not build a rocket myself? And I mean, I learned for 3 years, and one day I said, okay, now it's time to build a rocket. And that's where I started to, start drawing rockets, start building rockets, and it all seems very natural after all. I mean, I didn't know how to do it, but for the first time I did it, and it was very natural. And yeah, the journey took 3 years, and every time I learned something new every day until the moment I said, why not do it?
And so when you tell us about like the chronological order of like all of the from the beginning, like the first rocket you've ever done to now the prototype that you have right now.
Right. So the first rocket that I made, no, wait, I have to tell you something first. The first rocket that I ever launched was a rocket that I bought from Amazon. So my mom and my dad gave me a rocket already made at Christmas, and then I launched it in the middle of Italy, like in a field, something like that. And that was the first time I really launched a rocket. Then with the school, with my high school, we've tried to make a rocket, but for some security reasons, um, let's say, we've made a water rocket called Carus, and that one went, let's say, at 20 meters. So it wasn't really a very good rocket, let's say. It was my first rocket, but I really consider my first rocket the one that I built and launched in Molinella in October 2022. And that one was called Icarus. And that one was, I had so much feeling when the rocket, lifted off. I wasn't prepared, and that rocket launched and it went through the sky and it was amazing. That rocket had some problems that I fixed on the launch date, and then I made Daedalus, which was an upgrade version of Icarus, and then that rocket went well. And then I created Hercules, my last prototype that I've launched on October 2023. And that rocket was really an upgrade in technology, with higher strength materials and electronics and things like that. And that rocket went to 1,000 meters, but could have gone to maybe 5 or 6 kilometers. But I just sent it to 1,000 meters because that rocket and Icarus allowed me to get what we call the Tripoli certification of rocketry, which is actually a sort of license that tells you, okay, you can launch rockets and you can buy rockets, rocket motors, because you have passed the test. And in that test, one of the rules that is very difficult is that you actually have to launch the rockets and get it back and be able to relaunch it 10 minutes after, So if the rocket lands and you can not put a motor and relaunch it again, you don't have the certification. And that's the difficult part. The recovery part, you have to really think about it and have great materials and great connection bounds. And that's right. That's the chronological part of my rockets. And now I'm actually developing a new rocket, and I will talk it more about later on.
Okay, that's a great chronological order. I don't know if this is an unusual question for you or not, or you get asked this a lot, but how do you name your rockets? I'm always fascinated by how rocket names get inspired, and I know that many of them are acronyms of different letters, but what is the inspiration for you?
So I love Greek mythology and mythology in all forms, and I like the rocket to have a meaning. I think it's better for it to have a meaning and something like that, and don't have just acronyms and things like that. So Icarus, as said, Icarus is the first human being, let's say in mythology, to fly. So it's a great thing to use it as the first name of the rocket. Icarus, the first rocket, the first human to fly. And actually, in some version of this mythology, Icarus had gold feathers, gold wings to fly, and that's why I've made the Icarus fins. I painted them in gold. That's why. And the second rocket is called Daedalus because Daedalus is the father of Icarus. You know, Icarus went too near to the sun and burned the wings, and then fall in the ocean and died. And his father was wiser and more intelligent and was able to escape the prison which they were held. And so that's the thing. I mean, Icarus is the first rocket, the first human to fly. Daedalus is the more wiser one, is the father of Icarus. And then Hercules, I call it like this. I think I like Hercules, the mythology figure. I like it a lot. And Hercules was, you know, I said we need, for the upgrade of technology, we need a name that is more important. So, for example, Icarus and Daedalus were humans. Hercules is a demigod, you know, is a semigod. So I think it's better like this. And actually, a little story is that Hercules, you know, my rocket Hercules, had a lot of problems before launching. I mean, the fact is that the rocket was prepared for everything, even before launch. It was good to go and things like that. And every time on launch date, you know, there is always a problem with that rocket. And we had a lot of problems, but at the end, we launched the rocket and it went well. You know, so I like to say it was the 12 labors of Hercules before gaining the glory, let's say. So I mean, sometimes names might have a correlation with the rocket. And if I rethink about it, I shouldn't have called it Hercules because of the 12 labors of Hercules. But yes, so that's why I call my rocket like this, and I will always call my rockets with something meaningful, you know, with the purpose of the rocket. If the purpose is what if the purpose is a meteorological one, like scientific purpose and things like that, I will use Poseidon, because the waters and things like that should always have a meaning. And I think NASA and SpaceX should do the same. I mean, NASA did it a lot back in the 60s with Apollo, Gemini, and I was inspired also by that.
Yeah, I certainly agree. I think that having names that are inspirational instead of just acronyms of like letters of an entire sentence is tells a story. And maybe it's nice that you said that one name is the father of the other name, and it's like they're related and they give them personality for also the rockets itself. You don't feel like you're dealing with a machine anymore. It's like you build it, and then you see it grow, and then you see it launch, like from beginning to end. So that's amazing. I did want to actually ask you about the Triple E certification that you mentioned. How did you start on it? How did you prepare for it? Considering that I would assume that not all the people who take the certification are as young and ambitious as you are. So how did you, was there a criteria that you had to meet before you go for the certification?
So thank you for the question, because I mean, for the people that wants to build rockets that are watching us, it's really important for you to have the Tripoli certification because it allows you to build rockets and gain experience and challenge you a bit, you know. And so to get the first level of the Tripoli certification, you have to subscribe, let's say, to go on the Tripoli certification website and to sign up. And then you will have to get some papers. And when you're launching, normally there's someone from the prefecture of Tripoli certification that will be on the launch pad that will see and confirm that your rocket is able to relaunch it. You're able to relaunch it, and that all things are good for you to have the triple certification. And then they send those papers back to America, and if it's good, you get like a card with your Tripoli certification permit license. For the second Tripoli certification, however, you will need to pass also a written test, a written exam, and about security, about launching rockets, about design techniques, tips, things like that. And then you will need to launch your rockets. So it's a two-part exam. And for the third Tripoli certification license, that is a bit difficult because you will need to get someone that already has the level 3 certification of rocketry and actually design the rocket. You design the rocket, but he has to confirm that the design and things like that are good, you know. And furthermore, you will need to specify everything you do. So if you add a screw, you have to tell, okay, I'm adding this screw for this purpose, only for this purpose. So it's a little difficult to get the Tripoli certification, the level 3 Tripoli certification. And yeah, when you have
How long did you take you to prepare for it or study for it? Because it's inspiring that you kind of, before you went through this whole journey, it's been relatively recent. Like it's been a few years for you. So
Yes.
it feels like you went from zero to certification in a relatively short time. So how was stressful the preparation and how did you get to that and achievement?
Yes. So, well, for the level 1, you have just the rockets, you know, you just have to prepare the rockets. And that's a duration of 6 months, you know. It's 6 months that you start designing the rockets, then you have to find the building supplies of the rocket. You have to figure out if the rocket is stable, which motor are you going to put in your rocket, and actually build the rocket. You know, you have to glue things in a certain way, and that is the most stressful part. You know, then you arrive to the launch pad and you see if your rocket is done well or if you have to change something. And yeah, so the preparation for the level 1 is actually building the rocket itself, and that's, I think, is a great that you can actually start the triple certification even if you are not experienced, you know, in the field. and that's great. For the level 2, you know, you have to study hard for the exam. So this is quite stressful. I started studying 1 month before because, you know, I like more to study really hard 1 month, and it's better for me. And the rocket took also 6 to 8 months, you know. Then you have, I mean, it really starts with an idea. And I have to say that sometimes you don't know how to do the rocket, and you figure out on the way. Uh, sometimes the idea comes when you're sleeping, and you just, oh, that's the solution to my problem. Let's do it tomorrow, and it works. Or sometimes you find out it's not a good idea, and you think again, and you find always the idea. You know, sometimes you don't have to know. You will find out on the way, and with experience, that feeling grows larger and larger. I can't hear you anymore. I can. Oh, maybe you have your microphone. Okay.
Yes. So do you usually work solo on your rockets? Do you have now any person who is interested to join you and just to look or observe or assist you? I know that your father is an engineer. So do you feel like he's also involved? Like what kind of environment you work with?
Well, 90% of my time I work alone in my bedroom, but then you have 10% of the time where my father helps me, you know, to keep the things fixed and help me to glue because you need 4 hands rather than two. And also, my grandfather is a axsmith, so I do sometimes some work with him, you know, to create some metal piece. And he's a very good axsmith. He has like 50 years of experience, something like that, and still working. So, so that are my two main people that help me with rockets. Then I have my mom that is very supportive. I have to give credits to her because that's important. And my little brother also sometimes helps me and makes do some video or for Instagram and things like that. But 90% of the time I work alone, and maybe now that I'm planning to make bigger rockets, I will need to, you know, give some work to people, and I need someone also for things like software. I'm not so good at software. I better prefer give it to someone, you know. And maybe I'm going to university, you know, and I think there I will find some people that will be interested into joining the adventure, and I hope so because that's also the part of, you know, building a team and building something that is great. And you cannot work alone. That's impossible. Uh, when for my first rocket, it was okay to work alone because, you know, it's okay. But when you start to get bigger rockets, even for, you know, getting support or getting advice, you know, advice are very important to get advice for and talking with people. Sometimes I talk with my mom about ideas. They don't she doesn't really understand the ideas, but the fact that I talk to my mom about the ideas is helping me out a lot, and that's important also. So maybe in the future, I hope that maybe this year I can collaborate and work with someone. Yeah, like this.
Do you think that I also wanted to ask you about the club that you established? I would assume that you might also have a network for support there. So tell me how you had the idea for the club. How did it start, and how did you take it forward?
For the club, you mean?
The the IMF,
Yeah.
International Martian Federation Club.
Yes. So I started it as a club. Uh, I had the idea when I was 14, so back long time ago. Well, long time ago, 3 years ago. You know, time passed very fast, but um, so IMF Rocket stands for International Martian Federation, because international, because I want actually to create a network of companies and a network of people that will eventually get us to Mars. You know, maybe you need someone that makes the engine, someone that makes the life support systems, and that's a goal that I want to dig out further in the future. And that's why international. I don't want to have boundaries of nations. That's really important because maybe the Indians are good for support systems. Americans, United States are good for engines, and China for navigation systems. But I really want to collaborate with everyone. Martian, because the goal is to go to Mars, and Federation also takes into account all the companies that are bounded together, like something of a federation, you know, federation of companies or federation of nation. I don't know if nation won't work also to together go to Mars, and that's the important part. That we cannot go, like I said, we cannot do something alone. We need someone that help us, and to go to Mars, that is the greatest adventure of humankind right now. We cannot do it alone, and we will need the support of everybody on Earth. And so that's actually the purpose of the club. So, you know, when I was 14 years old, I just wanted to make it a club. But I have this idea long term to make something like that. Oh, sorry, I can't hear you. Wait. Yes.
You're right. Like science and engineering have brought nations together. Like, look at the International Space Station, where everybody collaborated and they kind of moved beyond the Earth problems and conflicts and did something much greater for humanity. So, yeah, that's very inspiring.
Yeah,
So, okay, so let's dig into some of the intricacies of like rocket building.
right.
Um, Before we do that, though, I'm interested to know that what was the first thing that you had to learn to build a rocket? Like, obviously, it's a very, very big, complex subject, but what was the keystone knowledge that you thought that once you unlock this, it will make things easier?
That's a great question, actually. Um, hmm. Think the first thing you need to learn is how actually the rocket is going to fly. I mean, what forces surrounds the rocket? What makes a rocket fly? I mean, if you don't do nothing on an object, it will rest. It will be at rest. That's the first law of Newton. If nothing happens on an object, it will be either at rest or in motion, in uniform motion. And so you need to think what forces are on the rockets. So the most important one is how the rocket is going to go from the ground to a certain altitude. And that is explained by the third law of Newton, that says to every action that you push, you have an action, you have an equal reaction. And that's the most important, let's say, equation of in rocketry, is that in order to move something upwards, you have to push to eject something downwards. That's essential. That's the most important part, I think. And then you need to think also that there's air. We don't live in a world without
Vacuum.
air. So what is slowing down the rocket? Is it drag? Is it some magical thing? And you have to figure out also that, and how it will affect your rockets. So you will have to make a nose cone that cut through air, in order to limitate this drag and make the rocket go higher. And then you also need to think how the rocket is going to go straight up, because it can go sideways and doing some loops. And that's the importance of stability. And stability is achieved by learning about lift, which is a similar force to drag and also works with air. And actually how this works is that the rocket is going straight up, and we have some winds that perturbate the rockets. And the fact is that when you perturbate the rocket and you have fins, what we call fins, a force that is called lift. So imagine the rocket is going sideways. There's a force that is called lift that is applied on the fins that makes the rocket go straight up again. And so you need to learn about lift and what is a restoring force. So yeah, you need to learn about forces and how rockets fly. And when you know that, 50% of the things, and then you figure out the rest.
Yeah, sounds like physics is the foundation for everything.
Oh yeah, physics. It's great physics. I love physics. It's my favorite subject of all. Yeah.
And so tell us about the what materials, because obviously you have started you're a self-taught person. So what is the progression of the materials, and how sophisticated, what was the earliest materials started, and how sophisticated have you come?
Maybe you will be surprised, but the first material that I used is cardboard. Cardboard, like the one you
Amazon
get.
cardboard?
Yes, Amazon cardboard.
Amazing.
And for the tubes, for the main part of the rocket is cardboard tubes, because you don't realize, but sometimes they're very strong. They're very and very light and very strong, and also that's why we use them to ship things and getting things done. And also another material that helped me a lot is 3D printed material, because with 3D printing you can actually make everything you want. 3D printing for building homes, and how it can be great for the future and for everything. So 3D printing is very important also for rocketry, and a lot of parts of my rockets are made with 3D printer. Plastic.
Is it polymer? Okay.
It's
Plastic.
PLA. Yeah, it's PLA.
Okay.
And no, maybe someday I will do like SpaceX and use aluminium 3D printing and steel, but I'm still on plastic PLA, the simple one. And yes, so I did my fins with 3D printing for my first two rockets and also the nose cone. And for the third rocket, I said, let's level up something. And so for the body tube, I used what we call the quantum tubing, which is a very strong PVC tubes, especially made for rocketry, and is very, very strong. I mean, is you can take a lot of shocks during flight. And for the fins and the nose cone, I used fiberglass. So
Hmm.
you can see you pass from 3D printing to fiberglass, and that's actually a milestone. And then for the first two rockets, for the interior parts, I use 3D printing, and for the last rocket, I used aluminium. So
Hmm.
it's very different with a CNC machine and um, things that my grandfather has in his office, and
Wow, that's very convenient because I was going to ask you how do you access the equipment that you need and the tools. But
yes.
yeah.
Well, 90% of things I do at home, but 10% of things I do to my grandfather laboratory. And um, yes, if I need to drill something in aluminium, I do it there. If I have to cut fiberglass because fiberglass is very um, strong, I do it there. But um, I do a lot of things at home in my bedroom, actually. If we're talking about PCB design, electronics, software, um, actually integrate and building the rocket, I can do it at home for now. For now, and and yes, that's the evolution of materials.
Is there any part of the rocket that you build is off the shelf that you don't make yourself? Like, what about
Sure.
the motors and where do you get the propellant?
Yeah, so actually, I don't want to buy motor, not to make motors at home because otherwise my mom don't let me, and it's very dangerous. I have to say, you will you to in order to make a motor, you need to have um, um, a laboratory, and you have to go to an extensive design. Yeah, that in order to make a motor, you need to do extensive testing, and you need a lot of money to do that. And I mean, you can buy motor online that are more efficient most of the time, and less expensive if we see on the short term of things. And yeah, but if you actually want to make a motor, you need at least 2 years of development, and I don't have time to do that, and I don't think it's great to make solid rocket motors at this scale. Sure.
Where do you get the propellant? And what type of formulations do you use?
So the propellant, you can get it on dedicated websites
Hmm.
that sometimes ask you even the triple certification in order to buy them.
Hmm.
And it's a mixture of aluminum powder, which is the oxidizer, and ammonium perchlorate, which is the fuel actually. And you have more things. You have a binder to bind them together. You have other type of chemicals too. increase the efficiency and the thrust and the duration of the motor. But essentially, you have those kind of chemicals: aluminium powder and ammonium perchlorate.
And from just a safety point of view, I know that you said it's dangerous to build the motor itself, but where do you test for launch? I know that there must be certain clearances around, because you said that you went up to 1,000 meters. That's a long range for a homemade rocket.
Right.
So where do you test them?
So safety is very important in this field, and the rocketry and the Tripoli rocketry certification points very closely on that and say, okay, you don't launch until you're certain, until you're safe, and things like that. So actually, there's some days that are organized by some association all around the world. That's great, I think.
Mm.
America, in the United States, has a lot of those kind of events and things like that. And in Europe, a bit less, but still you have one in Italy where I usually go, which is in Molinella. Molinella is called, and they organize launch all year long. So whenever there is an event, you can go and launch rocket safely, because actually they have the equipment and to make you safe and launch rocket at a distance, and so that's the most important part. Then the usually the rocket launch are made in small airports, so that
Mm.
the ground control can ask, okay, is there some plane in the range so that we can launch? And if you go higher, eventually you need what we call a NOTAM, which is a which is kind of an authorization that says, okay, at this time of the year, you can launch rockets until whatever in this zone, And yes, so then you launch also in a field in order to don't have any house houses and things that could be destroyed if a rocket, because when a rocket goes well, it comes down at 30 kilometers per hour, which is okay. But if it's not, it's going down at 600 kilometers per hour. So that starts to become fast.
And I guess that you also have to think of where it's going to land, so where you can retrieve it, right?
Sure, sure, sure.
Did it
Actually,
ever go somewhere where you said, "Oh my god, I can't believe it went there," or it's all
I
planned?
actually have a story about that. A very funny story. We just bought our car, and and we park it very far from the launch site in order to don't have problems. And we launch rockets. We go, and it was, I promise, so the car was here, and the rocket was at like 10 centimeters from the car. My mom was so pissed off. It was so funny, but
Wow,
uh,
so lucky.
so lucky. Yes, yes, yes.
That's-
But the probability that the rocket went there was very, very low. And so that's the funny part of this story.
Was it like a wind issue, wind velocity? What happened there?
Yeah, maybe a change in wind velocity, because we waited like 20 minutes before launching, because we had planes coming by, and maybe the wind changed, and it went near the new car.
um, That's funny and lucky at the same
Yeah,
time. So let's move to the portion of the topic of like the learning part of what you've done.
sure.
So you did learn through YouTube. That's absolutely amazing. I mean, I always feel that right now in 2024, I don't think that as long as you have access to the internet, I don't think there's any excuse for anyone not to learn anything that they want.
You're
Beyond that, it will be very personal choice that you choose not to learn it. It's not like it's not available for free for
yeah,
you to do it.
sure.
So, but people still or students still go to school and we still learn and we still have to sit in a classroom.
Hmm.
So for someone like you who is able to teach themselves something, because you know how there is the saying that says, "Oh, it's not rocket science," because the idea is that rocket science is like the most complicated and everything else is just still below that. So
Sure.
from that saying, and you were able to learn it still through YouTube, what do you say that since you are in high school and you are still in a classroom, what problems is there in the classroom that needs to be fixed so that people can still go and learn
Sure.
what they want and keep it interesting, if you
Sure.
know what I mean?
Sure. The first thing I will say is that if you're determined to learn something, you can. Like nowadays, you can do anything you want. If you're willing to, you can do anything you want. And I think the problem with school, with education, is that they um, they school are programmed to sometimes lose the curiosity that kids have. If you go in a kindergarten or primary school, there is a lot of kids that are asking questions and questions and questions about things, and they're very curious. And then you go to high school and people are just bored, and I think there's something wrong that's happened in that gap, and I don't think is the kids. I think is the school, and maybe if there were more interactions and less pressure from the grades, maybe it would help. And yeah, I think education can be changed in something more practical, something more practical. And I think, yeah, I think the school doesn't really give you a choice on what you want really to learn. And you cannot, for most people, it's very difficult to find passion and the will to study in school, because they don't school doesn't allows you or give you the opportunity to find your passion, find your what you want to do and stick with it. And uh, you know I think is we can
Yeah,
change. It's important to go
yeah,
to
I
school,
agree.
but we can change
Yeah,
school.
I agree. I mean, there are multiple ways to look at it. You can say that in schools, there are certain foundational knowledge that people need to possess in order to transition through life, which I understand. At the same time, on the other end, you would say that the school gives you the one size fits all learning experience.
Hmm.
Like they have one solution that everyone has to adhere to, even
Sure.
though after you finish high school everyone goes to their separate ways. Some people are doctors, some people are artists, So the fact that you have to go through a system that gives you a one size fits all solution is probably what makes people less interested, because only those who are interested in that solution would be interested to learn more about this topic. But if you're an artist and you have this creativity inside of you and you don't get to paint or to play music, or if you're a person who's into sports and you don't get to do that during the day, of course you're going to feel unmotivated to learn. And then you would have to turn into YouTube to do that.
Yeah, YouTube is actually a great educational platform, and I will defend that every time. And that's right. That's if you don't have, not everybody likes school. There's some people that are good at school, some are not, but that doesn't mean they're dumb, because people think that if you're not good in school, then you will be a failure in life and things like that. But I don't think it's like this. I mean, people can do whatever they want. And if they're good in school, then right, they will do maybe longer studies and things like that. But if they don't like school, maybe they're just, like you said, artists that wants to paint, or people that wants to travel the world to become and learn languages to become international, politicians and things like that. I mean, school is not every time the solution for everybody. And
Yes, you're right. And I kind of have to add that school will never be as updated as YouTube and the internet. Like, no matter how much a school is innovative and they want to make sure that their students are up to date with everything, they can never keep up. So even if they want to update their system, it's going to take longer than someone who's interested in something to have access themselves. So there will always, I think, there will be a gap between what people, and because we are living in a world where everybody has a niche now, like you're no longer just a doctor or just an engineer or just a artist.
right,
You're kind of, now people have to look for that specific new ways to stand out from the competition, and that's where you need to find your own way, and the school will probably give you the baseline and the foundation, but it won't give you the edge, that extra edge that you have to gain on your own. So
right.
it's very inspiring that you learned that on YouTube. um, it's a really good um, case study on what you can do with free access to internet.
Sure,
So
sure. And to people that are not only interested in rocket science, I know that every subject you can learn on YouTube. I learned rocket science, but someone can learn philosophy on YouTube, or Python, or things like that. You can learn everything on YouTube because people are there also to educate. And I think YouTube is a gift that was given to us. Sometimes you say there's some dumb thing on YouTube, but I really like YouTube for that reason, that you can learn everything you want. And if you're willing to learn, to watch a video for 4 hours, you can learn more than 2 weeks at school, I think, at least, you know. Sure.
to now, like, to transition to kind of the future and your future, how do you see now AI in the future of rocket building? Like, how do you find its role, since it's we are still at the kind of a beginning of what we can see it can do? So tell us more.
So I use AI just to accelerate my research. For example, if I need to find something very, very specific in a book from NASA in 1973, I look at ChatGPT and ChatGPT gives me the answer, but you will only need to search, do some research on that. And AI in space will be very important for designing spacecrafts, for designing things um, that a normal computer cannot do, and that maybe some humans, from some engineers, cannot think about. AI can be also great, I think. Another side of AI that could be great if astronauts, when they will go to Mars, they will be alone, let's say, no contact with other people. If maybe there's an AI that can generate your home or can generate things you want to see on Earth, that will be great also for psychologic effect on the human body. And AI can be great also if to control the ship. I mean, sometimes you need to give the commands to a computer on ships, and they will just uh, do the better choice every time. But can that this can be dangerous also. But AI have a lot of future in space. I mean, all subjects have a great future in space, and that's what I like about space exploration. I mean, think of every subject. Even psychology has a role, medicine has a role, education, because you will need to educate maybe astronauts to how to do things on Mars. Every subject has a meaning when you're talking about space exploration. Sure.
And speaking of space exploration, what are the most advancement right now from whether it's rocket or anything else in the space industry that you're most excited about?
So I have to say that Starship is very cool, and I hope they will succeed, because that could be a game changer to future space travel. I'm really excited about technologies that are not yet developed but are just a genesis. There's some grains going on. I mean, rotating detonation engine, for example, that NASA has just tested, can be a great fit for future spacecraft. I really like the idea of a nuclear fission engine, thermal fission nuclear engine. That, I think, is going to be the future. And I hope that I will be part of this future, because I want really to develop this kind of technology. And I hope also that the development of ion thrusters, the problem with ion thrusters is that they have a very good efficiency, but very little thrust. And there's some research and development that are being made today, which will be increasing the thrust. And I hope that someday you can use them to power a very big spacecraft, maybe in a decade or two. But I mean, there's a lot of technology going on that can be great. I think another technology that has to be developed is how you can, let's say, block or deflect radiation from space when you're going to Mars. And yeah, I hope that we will develop those technology also. But I'm very keen on the future, and in the few decades, we will have a lot of achievement made in this field. I think we cannot go to Mars with the actual technology that we have today. Even Starship, which is very, very good spacecraft and absolutely magnificent, um, they will need new technology. A recent development that I liked is the new Raptor V3 engine, which looks absolutely gorgeous because there's very few parts, and I don't know how SpaceX did this engine. They cut off weight while increasing ISP, and thrust is amazing. You know, amazing engineering. It's very incredible to see what human ingenuity can do. These days.
Yeah, certainly. And speaking of human ingenuity, so what's your next goal? I assume I'm talking about the goal that in the near future. I'm sure that one of your goals would be probably to fly on one of your rockets one day, hopefully.
Yeah, sure.
We all get to talk about them the same way that we're talking about all the other cool rockets. So before that, what's your next plan for now?
Well, now I have a project with a resident from Monaco asked me to launch a rocket with a specific purpose that I'm sorry I cannot reveal to you, but is a very very original purpose. It's a
Hmm.
first kind of mission, and this rocket will go to space, to near space, and hopefully come back. And it will be a two-stage rocket. And yeah, I'm actually working on that. And I've just made the first parachute because we will make some homemade parachutes. And so I just finished building the first parachute with the help of some sewers. Um, and I really hope this project will go on. And I have another crazy project that I want to do, and hopefully it will get done. Is to launch Hercules, my last rocket, from the lodge of Monaco. Monaco, Monte Carlo. Um, so the rocket will be launched from 2 kilometers from the coast, and hopefully it will be seen from all points of Monaco, and also that will be a first in a you know first kind of mission, to launch from the Lodge of Monaco and to 1 kilometers of heights, like my last rocket, Hercules. And I calculate everything, and the rocket is light enough to be floating, with Archimedes' law in the water. And
Wow.
so I want to develop that, and hopefully it will be get done. uh, I still have to convince the authorities of Monaco, but I hope they will be excited about this project also.
So, as a person who's going to be an observer and cheering for you and the rocket, I just hope you get good footage from multiple angles so we can all enjoy how it looks
Sure,
eventually.
sure, absolutely, absolutely. You can come to Monte Carlo, see also the rocket.
Oh,
uh,
that would be amazing! If you give me a heads up, I would be very happy to be part of it. It would be
sure,
very cool. Yes.
sure, no, for sure. I mean, I hope that a lot of people can see it, and the people that are interested about it the most. I really want to inspire people, and there's space exploration is growing and is growing very fast, and we will need aerospace engineers, and we will need to find those aerospace engineers and inspiring them. We need not only aerospace engineers, we need passionate aerospace engineers. And I hope that I will be able to inspire maybe one day those young generation of aerospace engineers.
I'm sure you already do that right now. I hope you keep doing this. We need more people who get kids and others inspired about important things in science and things that are good for humanity.
Hmm.
Um, I really enjoyed this conversation. I really do. I learned a lot about you, and I am very happy that we did this. I usually have one final question.
Sure.
Uh, is what is that one question that you want to be asked but you're never asked? I probably um, maybe should have asked you so that you can think about it more. But if you have anything now that you think that uh, you feel like you want to talk about, I'm
One
listening.
question that I've never been asked. Hmm. Huh. A lot of people say to me how you do it, but not so much people ask me why I do it. And the reason maybe that I want to do it is that I want maybe to be remembered as space explorer. You know, I want to be remembered as a space explorer, and you know, I was always always have this conviction that I want to do that, and I really want, and I hope that someday people will remember me as uh, a great rocket builder and a great space explorer, and I hope that I can do great things for maybe humans, maybe a little part, but maybe a little part will do the job, and that's it. That's what I want to do to help advance humankind, maybe even a little, but still, I want to do that.
Thank you, Alan.
Thank you so much, Tara. Thank you for my first podcast. I absolutely love it.
Thank you. Thank you. I don't know why I hit record by mistake twice. That
Sure.
was great conversation. I hope that I I didn't overwhelm you with questions, and I hope you enjoyed it as much as I did.
Yes, absolutely. I love it. Thank you
No
again.
worries. I'm very happy that we did it, and I really hope you enjoy your vacation. I hope I didn't take too much of the fun times.
So,
And my best regards to your family
mhm.
and to you. Good luck.
Thank you so much. You too. Have a
Thank
great
you.
day.
You too.
Bye. Bye
Bye.
bye.